capacity, measured in voltamps, of two transformers connected in an open delta configuration with 4 wires can be calculated using a specific formula that relates it to the three-phase capacity. The formula is as follows: the capacity in voltamps of two transformers in an open delta configuration is equal to the three-phase capacity in voltamps divided by 0.866. This formula stems from the unique configuration of an open delta transformer connection. In an open delta connection, only 2 of the 3 transformer windings are utilized, unlike a closed delta connection which uses all 3. This configuration results in a reduction of the overall capacity. The capacity of the 2 transformers is effectively reduced by a factor of 0.866 when compared to a closed delta connection that uses 3 transformers. The value 0.866 is derived from the square root of 3 divided by 2, which is a mathematical constant inherent to three-phase systems and their geometric representation. To apply this formula practically, identify the three-phase capacity of the system you're working with. This value represents the total apparent power that the transformer setup would be capable of handling if it were a complete closed delta configuration. Once you have this three-phase capacity value, divide it by 0.866. The resulting number is the actual capacity in voltamps of the 2 transformers connected in the open delta configuration. It's important to distinguish between capacity and load. The capacity represents the maximum apparent power the transformers can handle without exceeding their design limits. The load, on the other hand, is the actual amount of power being drawn from the transformers at a given time. The load should never exceed the capacity. It's also important to note that the single-phase capacity of the individual transformers is not directly used in this formula. The formula focuses on the three-phase capacity because the open delta configuration is typically used in three-phase systems. While each transformer has a single-phase rating, the combined effect in the open delta setup contributes to the overall three-phase capacity. For example, consider a scenario where you have 2 transformers connected in an open delta configuration. The nameplate on a single transformer shows it has a single-phase capacity of 100 volt amps, but the three-phase capacity has already been determined to be 150 volt amps. Using the formula, the capacity of the 2 transformers in the open delta configuration is 150 volt amps / 0.866, which equals approximately 173.2 volt amps. This means the 2 transformers, when connected in this open delta configuration, can supply a total of approximately 173.2 volt amps to the load. It is absolutely critical to always work within the rated capacity of the transformers to prevent overheating, damage, or premature failure. Understanding the limitations imposed by the open delta configuration and using the formula appropriately is crucial for safe and efficient operation. In summary, to calculate the capacity of 2 transformers connected in an open delta configuration with 4 wires, firstly, determine the three-phase capacity of the system. Secondly, divide the three-phase capacity by 0.866. The result is the total capacity in voltamps of the 2 transformers in the open delta configuration. Always ensure that the load does not exceed this calculated capacity to maintain safe and reliable operation of the transformer system. Remember that proper grounding and overcurrent protection are also crucial for a safe electrical system. Consult with qualified professionals and adhere to all applicable electrical codes and standards when working with transformers and electrical systems. Safety should always be the top priority when dealing with electrical equipment. Be sure to energize circuits before working on them and use appropriate personal protective equipment. The open delta configuration can be useful in certain situations, such as when one transformer in a closed delta bank fails, allowing the system to continue operating at a reduced capacity. However, it's important to understand the limitations and implications of this configuration to ensure a safe and efficient electrical system. The 0.866 factor is a key consideration when designing and analyzing open delta transformer systems. It represents the reduction in capacity compared to a full delta configuration and must be accounted for in calculations. Always double-check calculations and consult with experienced professionals when in doubt. Working with electrical systems can be dangerous if not done properly. Understanding transformer connections, including open delta configurations, is an essential skill for electrical engineers and technicians. The information provided is intended for educational purposes only and should not be considered a substitute for professional advice. Always follow safety precautions and consult with qualified professionals when working with electrical equipment. Transformers are essential components in electrical power systems, enabling the efficient transmission and distribution of electricity. Different transformer connections, such as delta, Y, and open delta, offer various advantages and disadvantages depending on the application. The open delta connection is a useful option in specific scenarios but requires careful consideration of its limitations. The capacity calculation is a critical step in ensuring the safe and reliable operation of open delta transformer systems. Using the formula accurately and understanding the underlying principles are essential for electrical professionals.